is the FRC Roundtable, coming to you all the way from Minnesota. Your host team 2052 Nightcrawler presents this weekly FRC gathering where FIRST Robotics competition teams take cooperation off the field. Share your knowledge, give and get advice, solve a challenge, or celebrate what makes your team special. 3, 2, 1, go!
All right, the recording has been started. Welcome everybody to tonight's roundtable. I have a little story to share to start off on how we got these presenters tonight. So Emilio and John were giving a presentation at Jumpstart Medtronic over the weekend. And it was in the first session and I attended that session and they did an awesome job. And they were taking Q&A and I raised my hand and I said, hey, would you be willing to do this again on a Sunday night call? And they said, yeah, sure. And I said, what about tomorrow night? Because no one signed up. And they both agreed. So thank you so much for signing up to do this. I really appreciate you kind of helping take some load off of me so I don't have to come up with something for us to talk about. And I think our crowd is pretty big tonight because they were probably at Medtronic and heard about it, so they want to get more info from you guys. So with that, the floor is yours. Please introduce yourself. Tell us where you come from, what team you're on, and role in the team. Whatever you want to cover, go ahead. The floor is yours.
All right, I can go first. I am John Malvin from Team 3082 Chicken Pot Pie. I am the programming captain on the team, and I've been on the team this is my third year now. I'm a senior, so my last year as well.
Hi, I'm Emilio. I'm also a programmer on Team 3082. I'm a sophomore, and this is my second year with the team. So I guess without further ado, I can start presenting my screen. And if I just go to slideshow and just we have this for now. Okay. Can everyone hear me? Fine.
Yep, you're good.
Okay, so guess I can just minimize this in the background. This is custom trajectories by Team 3082. So what we're going to be going over today is really just the math behind curves, what is a spline, and following algorithms of pole pursuit, and little goals during auto, and what we're going to be trying to be aiming for, and Team 3082 suggestion for how you can get all of this on your own code base. Now, the first thing to start off with, before we get into the math, is just to define some basic terms. So a spline is pretty much just a fancy way of saying that there is a curved line going through specific points. Now, different types of splines have different quality to them. Today, we're going to be going over bezier splines because they're really simple and powerful, but there are many different types of splines as well, such as B-splines or contacted helmet, but those are outside of the scope for today's presentation. Now, before we can really get into what a bezier spline is, we need to define a math concept called linear interpolation. Now, linear interpolation is really just a fancy way of saying it's a function between 2 points. Now, linear interpolation is a geometric function with the input being t, and t of 0 is actually the first point on the curve, and t of 1 is the second point on the curve. And the formula for a geometric function for linear interpolation is c of t equals p of 1 minus t plus c of 2 of t. Now, that may sound a bit confusing, but it'll make more sense when we show it in Desmos. Now, Desmos is a graphing tool for math functions, and it's really nice for graphing some robotics, splines, or curves when you're designing your autos. So in Desmos, if we define 2 points, say P1 and P2, we have 2 points on Desmos. Nothing really fancy going on there. But if we use linear interpolation, we can define a function to get a point between these 2 points. So we do P of 1 minus t equals P of 2 plus P of 2 times t. You see that we get a straight line between these 2 points. And that's really the core concept of linear interpolation. You get 2 points, and for different values of t, you get a line between them. Now, it's important to remember that for given values of t, what you're actually receiving is a point, so an x and a y. So you have an input of t, which is between 0 and 1, and you get back an x and a y as a point. Now, the question is, how do you get from this line to this Bezier curve? And the answer is you add a lot more control points. So we go over to this next Desmos walkthrough. What you can see here is that we have 4 control points, P1, P2, P3, and P4. But the first step for getting a point on a Bezier curve is you want to interpolate between these points. And as you can see, as we animate it, we keep getting 3 points on these 3 interpolations. Now, the second process really for getting a point on the curve is you just keep interpolating until you cannot interpolate anymore. So if we do this a second time, you can see we have even less points to interpolate from, and you can already see that that point is starting to do interesting behavior. And if we interpolate a final time, we actually end up getting a point on the curve. And if you follow that point, you can see it kind of going in a arc-like motion. And the really nice thing about Bezier curves is the complexity of the lines you can generate from them. So if we actually end up graphing this out, you can end up seeing a really useful line, which is doing that motion. Now, the reason this is so helpful is because it allows you to easily move around game objects on the field. For example, if I pull up the field from last year's game Crescendo, you can see that maybe we want to have an auto that starts at P1 and like ends up here. It's really easy to use Bezier curves to generate a path that allows you to move around those game obstacles. And that's why Bezier curves are so nice, because A, they give you a lot of control, and B, at the end of the day, they are using just one math concept of linear interpolation to generate that point on the line. Now, theoretically, with Bezier curves, you can have an infinite number of points, but I wouldn't recommend going beyond 4, because as you have more points, it becomes more difficult to actually control the curve, and it also becomes more math heavy on your RoboRio or like your path generation algorithm, as it has to perform a lot more interpolations. Now, John is actually going to be going over how to follow the path generated by this.
Yeah, so I'm now going to go over kind of how we want a robot to follow the path after we've generated it. And one method to do this is called pure pursuit. Go ahead. So what exactly is the pure pursuit algorithm? It's a pretty simple algorithm that allows for effective path communication or path following, but it's generally pretty simple, and it calculates both our angular and linear velocities to that the robot needs to take to follow the path, and that makes it possible to use it as well for tank drive, not just swerve, which is super useful for all types of teams. And essentially, it works by finding intersection points around the robot, around a radius of the robot, and drives towards those points. So if you go to the next slide, this is just an example of the algorithm working. See, the robot pretty effectively follows the path, but also has a little bit of inaccuracy while following it. But we'll get into that in a bit. Go ahead. So how does this algorithm work exactly? So you are able to, essentially you're drawing or looking at a circle around your robot, given a radius. And with that circle, you find the 2 intersection points on your path where your robot intersects. And you find the closest point to the next point on the curve, and you have your robot drive towards that point. Pretty simple, but it can have some little intricacies to it. But essentially, you're just checking those, you're updating again and again, and eventually it'll just follow the path by itself. Super nice. Some things to consider, though. I talked about that radius as a factor. That's generally called look ahead distance, because your robot looking ahead at the path where it needs to go. And tuning that is a really important part of this following algorithm. If you have it too small, you can see on the right. If you have a small look ahead, it's going to be pretty. When you're following kind of a curved motion, it can be a little bit inaccurate, overshoot a little bit, because it doesn't have that foresight that you might want for going around a curve. However, with a large look ahead distance, you might kind of overshoot or rather undershoot and not get the right motion in the curve, or you don't want to run into a game object just because you don't follow the curve well enough. So it's kind of, you have to find, for the look ahead distances, you have to find pretty happy medium to achieve kind of effective path following of your robot. But that generally takes trial and error, seeing what your robot, how your robot behaves, seeing the path that you need to take, and effectively looking at that to determine what your look ahead distance is going to be. And then another thing is you want to also avoid having no intersects. So if your robot doesn't have any intersections with the path, then your algorithm's not going to know where to go next. So obviously that would not be good for your robot. So you want to really avoid your robot moving outside of the path, and you got to just handle that effectively. And then also calculating rotation, at least with tank, you want to use a RAM set controller. It's recommended that you look at that for calculating your rotation velocity that you need to use to get to the certain point. You can go ahead. So I'll talk a little bit about specifically auto and our goals during auto. So we want to, during auto, be able to move smoothly and quickly across the field, while also being able to perform game actions while following our path. So if you go ahead, I'm going to talk about a little bit about how we might be able to execute those game actions while we're following the path. So first off, I'm going to talk about parallel commands. So if we want to be able to follow our path that we created, we have to give our robot a command to follow that path. But the problem with that is that you might not be able to simultaneously perform game actions while you're moving. So that's where parallel commands come in, and these allow for both your path following to be performed and game actions at the same time. So essentially, they're running simultaneously. Super nice. The only limitation to this, though, is that you the game actions that are dependent on timing, dependent on position more specifically, like if you have to be in a certain position to shoot or whatever, are really limited by these parallel commands, because they both it's not like a conditional, when you're at this point run this. It's just, it does them both at the same time. So you might want to use a different approach if your game actions need to be a little bit more they are dependent on timing specifically. So if you go ahead, wait, actually, can you go back 2 slides? So I'll talk about stop points here. So if you want to be able to be more kind of precise with your timing or precise with your positioning when you are executing game actions during auto, we recommend stop points. So these would be action points that allow for your robot to perform certain actions during your path following. Essentially, you're stopping your robot or waiting for your command to execute until and then you continue following after that. And this is kind of a more sequential way of performing actions while you're following that path while you're in auto. The only limitation, really the main limitation, is that it's timing. If you're only have 15 seconds in auto, it could be difficult to have a bunch of stop points in there as well, just because you have to have everything going kind of very quickly. So that's when you would want to use maybe more heavily parallel commands like I talked about earlier, but they're both pretty useful. So you can go ahead 2 slides. And I'll talk about a little bit of an example for how we structure our auto code for path following, and I'll try to explain it the best I can. So here we have like our command essentially. The most important part of this slide is specifically looking at like that controller. It's assigned as a generic in this, but that essentially means that depending on which algorithm we're using, we can kind of differentiate if we want to use a different algorithm. It's a lot easier to do that. We don't have to make a new class for that. But basically, all you need to know is that controller that gets assigned is the path following algorithm that we're using. And then we start our time, or basically a clock, to measure how long we've been following our path. Because like Emilio was talking about earlier, we are following our path based on a time t, not necessarily an x and y value. So that we want to have that as a factor for how we're following that path. So you can go ahead. And this is our update method, our kind of our big method for how we actually handle the following. We get all of our positional data and angular data of our robot, both position and velocity, and angle and angular velocity, just to kind of get a good idea of where a robot is and how it's moving. And then we assign that to a swerve state, which is essentially just holding all of that data so we can easily manipulate it or use it. And then we feed that into the swerve instruction based on our controller, or our algorithm. And then it allows us to, and that outputs essentially where our robot needs to move to next, which is super nice, super easy. And then based on that timing, like I said earlier, once it determines that our path is done, it just stops the robot. So that's about how we do that in kind of a simple manner.
So really the question of like, how should I implement this on your own code base is my first suggestion would be to get really familiar with Desmos. And then my second suggestion would be code a bezier class. And really the third of trajectory following, this is the most of kind of your choose your own adventure, because how you implement this will vary differently depending on your robot, how you set up your code base, and what classes you're using. But I'll like show the basics of a bezier class. So with Desmos for drawing, usually there's a lot of field accurate Desmos, and you can actually plan out your bezier splines and bezier trajectories here by just moving control points around and like jotting down those values. Now, it's really good that you get like a nice understanding of how Desmos works, as will not only help you actually make your trajectories, but it'll give you more intuitive understanding of how bezier curves work, so that way you have an easier time when designing your autos. Now, when you're coding up your own bezier curve class, it's really useful to have a helper class called point2d, because when you're coding up a bezier curve, you have a lot of different points, and you wouldn't want to have like 50 million different x and y values in your bezier curve class. So really, for point 2D class for Bezier curve, you want to have really one method. LOLP, this stands for linear interpolation. We would want to abbreviate it as LOLP, as writing linear interpolation a lot on your code base would get a bit tedious fast. But conceptually, it's doing the same thing as I showed in the Desmos. You're just taking the x value, you're interpolating it with another x value, and you're taking the y value, and you're interpolating it with another y value. And what you can do is you can make a Bezier curve class of this. So what you want to first do is define your full control points and have a constructor for that. But what you really need is to have a method called get points. And the beauties of Bezier curves is that you can see is that the same math function just being done over and over again until you get down to 1 point. So you just keep using that linear interpolation function for given values of t to get a point on the curve. Now, the question of how do I get my robot to follow this can be a tricky one depending on your code base. But if you're already using another path planner such as path weevil or path planner or just built-in WPI follow commands, what you can do is you can actually convert your Bezier curve to a WPI trajectory, and that way you can take advantage of built-in WPI followers. So how you would want to go about that is you want to first make a method called getTrajectory that returns a trajectory. And this returns a WPI trajectory, and that will allow WPI's built-in auto system, built-in commands and built-in followers to actually use your path. And what you need for a trajectory is you need a trajectory config, and these values will be different depending on your robot, but you just need to specify the max velocity your robot can move or you want it to move, and the max acceleration your robot can do. So these are statistics that you need to find on your own robot, and they will vary, but my suggestion for doing that, we're just going to be looking at your drive specs and working up from there. Now, what you want to do is get a list of waypoints, which is a pose2D because WPI uses a pose2D, which is really just an X and a Y and a rotation. So for given points, for given values of t, you would just use that get point method to get a point on the curve, and then you just add it 2 waypoints. And then you will return a new trajectory using the WPI generate trajectory function of your given waypoints and your given configuration. Now, how you would follow this is you might use a WPI command. In this case, let's say I'm using tank. What I would do is I would pass a new ramset command, which is a specific follower for tank that WPI has built in. So you would first pass your trajectory, and then you would pass all the other things you need, such as getting your robot's position, your ramset controls constant values, your modals volts values for that, and also drive constants and everything else you would need. Now, these constants are going to be differing a lot based on your specific drive chain, and you kind of just have to mess around with the values until you get something that works. So that's how you would actually follow a command. What Team 3082 ended up opting for its trajectory solution is developing a custom app called Chicken Planner, which allows us to draw Bezier curves and save them to JSON so that our code base can follow them. Does anybody have any questions?
Before that, Amelia, would you like to kind of demo that application, the Chicken Planner?
Yeah. So currently I have Chicken Planner written in Java FX, and the reason I opted for writing this application in Java is because WPIB is written in Java, and a lot of FLC teams know Java, including ours. It was best to write this also in Java, so that way more people can work on it in the future. So if we just run it, we get Chicken Planner. And what this is really is just a tool for drawing Bezier curves right now that can load and save to WPI projects. Some features we were looking into adding is what John mentioned earlier of stop points, and also some quality of life features such as being able to set positions. But currently, it's good for drawing curves and having a robot follow that. This is a project I would highly recommend teams trying to do if they want more of a challenge with trajectory following, as it teaches you a lot about Bezier splines and Bezier curves, and also it's just a really fun thing to showcase.
All right. Does anyone have any questions for us about the presentation?
I have a question. Could you demonstrate how you're using Chicken Planner to get the points into a JSON file that you could run with something like Path Planner? I see how you're using it to draw the bezier curves. I just want to know how you're getting those points to run it on something else.
Yeah, so
Amelia,
what
do you
we'll,
want to say?
so what we're doing is pretty much when you load a WPL project, it just creates a new folder called Chicken Panel, and it will just save a JSON of like kind of just a list of points. And then actually in our code base, we just have it run in real time and like generating the code for our pole pursuit algorithm to follow. So it's kind of like Path Panel and Choreo where you just like load a project.
I have a question.
Yes.
Based on your experience, would you say that this method, the previous method, is more accurate compared to tools like Pathfinder, or is it around the same?
I personally haven't had much experience using Path Panel, but we do find that using Desmos works well.
All right, thank you. That's nice to know.
Caleb, do you have a question?
So over the past summer, or maybe it's 2 summers ago, I worked on my own autonomous library just as like a learning experience. And a thing that came up was figuring out, instead of having your paths be over time, have it over a distance. Do you have any like notes on that, whether it's better or worse, or experience
Yeah.
with that?
So I will talk about kind of our experience last year. So last year we used Choreo. I used some images from Choreo on one of my slides for the autonomous thing, but so that gives us our data based on or we computed that based on time, but haven't really experienced based on distance. So I that at least worked really well for us. The timing was very accurate. Our paths during auto were generally accurate. Really, our only kind of setback was our odometry or vision. Generally our positional data that kind of messed up our path following. But at least for time, or at least for time over distance, it worked well for us. But we really only tested time and during our experience last year.
All right, yeah, thank you.
On that note with distance, with Bezier curves, instead of like just following it based off t, you can always just get a bunch of points on the curve and like use the pole pursuit algorithm to follow it in that way. Like kind of what's being demonstrated here. Yes, Lily.
I want to know your like process when you were like fine tuning the paths. Like, what did you do to like make sure your paths were really accurate?
So like what do you mean specifically like drawing our paths and making sure that they're lining up with our robot movement on the field, like
Yeah, like how did you like tune the paths so that it was accurate to what you want? Because I don't know.
no, that's a good question. So it was definitely a lot of trial and error. We used, like I said before, we used Choreo last year, which gives us kind of a good map of the field based on the field, the game field last year, and that allowed us to in the app draw out a path that was hopefully pretty accurate. But right, we did have to do some fine tuning to kind of achieve that, and that really came from trial and error, trying that on a practice field, on our practice field that we had at school, just testing autos over and over and over again to make sure the path was right, and then testing. Essentially, we would have to also test our PID values to make sure that our robot was giving us the desired behavior. Basically,
My
but yeah,
suggestion
to
with
answer,
my suggestion with tuning is try to start simple. Instead of like trying to follow a path force, maybe force just try to correct the robot's position and rotation and kind of build up in complexity. It's a lot easier to diagnose a like issue when you're just having the robot move left instead of having the robot do like a complicated path. So that's really my suggestion for tuning is like kind of start small. Maybe don't even start with position correction, just like start with like driving the robot around to kind of get an idea for how your robot reacts to certain movements and just kind of build up from there.
yeah, absolutely, yeah, definitely a good suggestion. Simon, you?
How hard is something like Chicken Planner? How easy is it to make, or how hard is it to make?
That really kind of depends on how complex you want the project to be. With my experience, it hasn't been terribly complex to make. It kind of just depends on what you're going for. So drawing bezier curves, what I ended up using Java effects for that. So well, the team did. So what we just did is kind of drawing a bunch of points to the canvas. We can definitely, if you want to research the chicken plant, the Team 4082, we can definitely give you a lot more advice and specifics on how to do that. But I wouldn't say it's a terribly complicated project. But if you're just getting started with your custom trajectory planning, maybe it's best to use Desmos for now and then shift to trying to build your own custom application.
Riha?
Okay, so when we started using Path Planner last year, we noticed that our robot, it doesn't really follow the paths. I mean, we use like a odometry to like measure the distances and stuff, and we noticed that our robot was doubling the distance and also turning. Like when we just tell it to go like 10 feet straight, and that would be like the only path. And when we changed like the wheel radius to like the correct size, it got more out of control. Like it just went faster and it was just like completely not following the path. And we're not sure why.
Sure. So like Emilio talked about earlier, I would really recommend like maybe taking a step back, like looking at implementing, instead of if it's not working, instead of using Path Planner to start off with, you might want to try just stripping it down to just PID, or just moving to a certain point on the field instead of kind of a big intricate path. That might be better, because it could be a variety of problems, right? It could be your odometry not being super accurate. It could be even something that, like, some input data that is um, you know give some input data that is kind of um, uh, looked at the wrong way, right? Calculated wrong. So um, I would really, like Emilio kind of recommended, start very simple. Just don't be afraid to start simple and look at, can we just drive our robot? Can we get our robot to drive X amount of inches forward, or rotate 90 degrees to the right? And from there, if it can do that, then start looking at, Path Planner, and look at, okay, let's try to replicate that in Path Planner. And then, because then if you are able to do that, you'll be able to kind of more easily diagnose what the issue might be. Does
Are
that
you
kind of
saying
make
to
sense?
do that within Teleop or do that within Autonomous using the PID values?
Probably in Autonomous would be better, just to test that out.
Because we've changed our PID values and it hasn't done anything.
To me, that sounds in particular like an odometry issue, because if it's like doing a precise doubling of distance, my suggestion is there might be something wrong, especially with the gear ratios in odometry, as that's like a really tricky place to debug, but also a really common place for issues to have with odometry. So I would really just maybe instead of like trying to like patch the odometry section of like maybe just it may be best to like actually kind of like try reworking that section from scratch and just like looking at your gear ratios again from scratch, like not looking at your old code and just kind of reworking that.
Deepak?
Yeah, so first of all, really, really well done, guys. Thanks for presenting at Jumpstart. It was really well received. You got a lot of good questions, especially about Chicken Planner. So I wanted to ask if you guys had any plans to make Chicken Planner kind of open source. There were some feature requests at your presentation for things like, having a field where people could select where they wanted a robot to be, maybe 4 inches to the left, as opposed to clicking and dragging for path planning. So could you guys talk about your plans to maybe make it more available to teams, and if you were going to publish to GitHub or however you're planning on rolling out Chicken Planner?
Yeah, so currently we have plans to make Chicken Planner open source. It's been in a bit of rapid development, so currently the Git structure and really the file of the code base isn't that welcoming to people who haven't been actively working on it. So our main priorities is just kind of refactoring a lot of classes and making things make more sense, while also simultaneously adding documentation. And once we reach that point when it's like able that other people can look at the code base and easily understand what is happening, we're gonna release it. Our main goal to release it is kind of like by the end of Thanksgiving break is when we're literally aiming to make it like open source and open for other teams to start working on it.
Yeah, Scott.
So my question revolves around rotation. So I see the Bezier curve. I see how that you create those points, but how are you handling the rotation, how you want your robot oriented when it gets to its destination in your custom code that you've built? And then additionally, with Path Planner, you not only can set the rotation of your robot, but you can also set the rotation you want your wheels oriented when it arrives at its destination. Have you guys figured out a way to solve that with your custom pathing code?
Yeah, so while we haven't fully implemented this in the UI, what we are gonna do is have an action point class. And in your action point class, you can specify things like rotation. I'll be adding more things to that as they're on demand. So I actually do really love that wheels idea. So what we can always do is we can maybe add like a wheel configuration elements to an action point and just draw that on the path. So a lot of things were done kind of like behind the scenes in Chicken Planner so far. We just haven't gotten into implementing it into the UI in a way that's like clean, but also easy to use.
Yeah, essentially, it would be like very like linear, pretty like linear rotation from point to point.
Right.
That's how it was.
I'm guessing
we use.
But looking at your code, I think I saw someplace in here where it says, what is your current rotation? What is the rotation you're trying to get to? And then you're doing some type of a math to figure out a rotation velocity or something like that. Is that right? Or did I misunderstand the code that you guys had up on the board briefly?
Yeah, that's correct. So what all like following code does is it kind of gets like the arrow in velocity and just the arrow in position, and we use PID to correct for that angle. So we use correct for angle position and angle velocity. So we're kind of correcting for both velocity and position. Something other interesting that we've been looking into Chicken Planner is our team actually developed custom auto commands last year that was like separate from WPM commands. And something that was interesting that we're looking into is maybe having it so that in Chicken Planner you can actually specify full auto routines by using like custom commands and just like having an interface above at plannable. So that way Chicken Planner will like read through your code base and then allow you to actually like fully code auto routines in the app.
To kind of add on to that, also our team's looking into kind of our own telemetry or network table solution, and we also might integrate that with Chicken Planner, being able to see kind of our path live while our robot is following it, to help with debugging and general things like that. Also, might be kind of a idea that we will follow through with. Any other last minute questions? All right. Amelia, do you wanna? Looks like in the chat here, got a. Do you want to pull up your example again,
Oh, yeah.
Desmos?
So if we just quickly pull up this example, let me actually send a link to that in the chat. So I guess I can just quickly walk through more what this example is doing. Definitely. So if we go into the Medtronic Secret walkthrough, what this Desmos really is just, it kind of like shows the main concept behind a bezier curve of it's just linear interpolation. So it's really the same formula repeated over and over again. Now the thing about bezier curves is that while you can conceptually understand them as just linear interpolation, if you actually simplify it down, you get something called the Castro's algorithm, which is this formula. It's kind of hard to understand what's going on here, which is why it's best to, like, when you're thinking about bezier curves, to think of them as linear interpolation. But if you simplify it down, this is the formula you get. And so this bezier curve, and really the best way to use this, if you're wanting to showcase this to members of your team, is you just kind of want to have like these deselected first, and then kind of just go down with Desmos and the bezier curves, and then just graph it out. One last side note, this field isn't to scale, so don't be using this to plan autos, but there's usually a scaled to field Desmos in Chief Delphi.
All right. Emilio, would you like to go back to the slides just so we got that last slide about our Swift thing on the team?
So our team is part of something called, we go Heal the Swift Initiative. So the Swift Initiative is really a kind of started off with the Taylor Swift fans sharing bracelets. And what it is a way to help girls and non-binary people feel welcome to STEM. And it really helps connect you with different teams. And it's also just a fun activity / conversation starter at competitions. So currently, FLC Team 2550 is hosting an event on December 11th. And actually, Chickenbot Pie is hosting an event on December 14th at Minnetonka High School at 2 p.m. So this is a really good way to just help more girls and non-binary people feel more welcome to STEM. And again, it's just a really fun way to have conversations and just like conversation starters with people at competition.
Yeah, and this is something that will, in terms of like networking too, it's kind of a fun thing. But we can all, show up. We would recommend you show up, and then you can always talk more about. Come find us, me or Emilio, and we can always talk more about our pathfinding things or just general robotics plans or news. But yeah, we really recommend anyone that is interested should show up to that. But you can also reach out to us if you have any additional questions, if you have more intricate questions that that require a little bit more time to answer, please reach out to us at our email, minnetonka3082@gmail.com, and we would be happy to answer those questions as best we can.
And when Chicken Planner becomes open source, we would definitely be like happy to invite other FLC teams to work on it. In fact, we may try coming back on here when we make it open source, I explain how it works and how you can contribute to the code base.
Yeah, I think that's a great idea. I'd love to have you guys have sort of an open source kickoff where you can walk through the project, explain to people how it works, how they can contribute. I think that'd be fantastic. Love to have you back for that. Any closing comments or questions? All right.
I have a question actually.
Go ahead. Fire away.
So for mini trials, the upcoming competition, our team has been trying to get autos to work on robots that are running tank drive. So we were using, like the example that you showed on the slideshow, a Ramset controller. I was wondering what controller were you using during the actual season? Because I know for Path Planner, it runs it using like a holonomic drive controller, but the ones that you would make manually using hard code only take in PID values and not anything like an array of points that you would follow. So how are you actually running those on like a swerve drive base?
So what we do for that is, actually, what our code ends up doing is it follows waypoints, but each waypoint has a specified velocity and position of where it would be, and we just use PID for given values of like time to just update for those values. So it's constantly just like shifting PID to a different set point, and that's how we actually follow the curve during season.
Okay, so not any like specific drive controller that comes with WPI lib, more of like connecting the points with just your velocity?
Yes, with just the velocity and position. We, as on Team 42, we kind of like making things more custom, so we don't use WPI collapses terribly much. The reason I included the code in the presentation was just to show you that you can still build custom trajectories while using WPI as kind of like a way to branch out. And actually on my final notes is try like making your own custom swerve code or like own custom trajectory code. It's really fun. It's really rewarding. Like just like kind of like still coding. Don't like worry too much about like how it will work or like if it will be successful. We're still in the preseason, so this is really the time to experiment and to have fun building those things and like kind of just like tinkering with what you can do before like build season starts, and it's kind of like a rush to get everything done.
Yeah, I completely agree. For our team, having our own swerve code built in kind of a custom way has allowed us to kind of learn more, but also it's good for debugging if we have kind of an error with swerve or whatever system we're using that we have custom. We know how it works and kind of their intricacies, and I would definitely second that and recommend. Yeah, if you're interested kind of in any of this, or yeah, I would recommend trying to build some more custom approaches.
And if you have like any questions on how you can approach that, or even if you want like maybe a person from another team to look at your code and give you suggestions, always feel free to reach out. A Chicken Pot Pie is like always willing to provide help to other teams. That's the really like lovely thing about robotics and gracious professionalism. We're a community and we always just help each other out. So feel free to contact us whenever you want.
Okay, I think now is a great time to give a round of applause. Thank you very much, fellas. This was awesome and amazing. I'm so happy you were willing on such short notice to hop on here and give your presentation again. Really, really excellent. I appreciate it. We do have more time left in the evening, and I'm willing to, I think it would be appropriate this time if anyone wants to pose a question. I think the topic of auto is a very popular topic. So let's start there. Does anybody have anything they want to share or any questions they want to ask just about auto in general, and use the crowd here? If you're specific to Path Planner, specific to Choreo, feel free to ask those, because there might be someone on here who has some advice or some tips, or share something that your team figured out that others might think is as helpful and valuable. Anyone?
I think a suggestion our team has in particular is really try taking advantage of those parallel commands. Autonomous period is a really short period, so anywhere you can optimize efficiency, but also making sure you still have a lot of reliability is really key. So use of those parallel commands will allow you to do more stuff in autonomous period and, of course, get more points.
Afomia, I'm going to put you on the spot here. Do you want to share some of the reasonings behind? So this year, Nightcrawler is trying to do more coding of our autos rather than using Path Planner to connect all of our commands. But I would like to see if Afomia would be willing to share some of our reasoning for doing more manual creation of our autos rather than Path Planner.
Couldn't find the button. Yeah, sure. So last year we were using just Path Planner. We weren't getting the points like you guys were with the Chicken Planner or anything. Um, and we had some problems with just in general the accuracy of the points from the GUI, but that's expected. A bigger thing was we had a harder time like integrating different commands and customizing what we were doing at particular points. That would have been easier if we were just doing hard code using things like you said, parallel commands and sequential commands. Um, I wasn't on the team 2 years ago, but the years before that, we were largely just using hard code to run autos, like path followers, things that were already on WPI lib, drive controllers. So we wanted to use, while the points were sometimes not accurate, Path Planner does make it much easier to kind of visually see the autos that you're planning, and dragging and dropping the points is helpful to have like a start location. So it was nice to be able to get the points in something like a JSON file, but it would be much more efficient and almost easier to look at and easier to integrate different commands that you're already running in your code if you can get those points and run them just using hard code. So we're probably going to try to combine those two things this year, which is kind of, I think, what you were talking about, how you're getting the points as a JSON file from your Chicken Planner or Choreo or elsewhere, and then you're running them in your hard code.
Some other things that we are hoping to do is that when Nightcrawler used to manually code our autos, you could build auto commands that had variables on the constructor. You can't do that with Path Planner. So if you wanted to have sort of a generic type of command that was rotate to a certain degree, you could put in your constructor, I want to rotate to the right 30 degrees, or I want to rotate to the left 60 degrees. And that's the exact same code every time. But with Path Planner, you had to have a rotate 30 degrees command and a rotate negative 60 degrees command. And so by manually coding it, you have the option to do things on the constructor. The other thing that we are interested to try to figure out is, like last year, you would run out to the center line to get a note, but someone may have already taken that note. And so we think that there's a better chance that we can have more conditional logic in there saying, hey, if the camera doesn't see a note, run this path instead. And so we're interested to see what additional flexibility we might be able to get by manually coding our autos, which isn't as easy to do when you have to snap them together with Path Planner.
Yeah, I think something Team 42 is looking into, like maybe this year, is trying to use object detection to detect if like a game piece is in front of you, and having you do a different path or different command based off that.
Yeah, we were looking into that too. That's another, Scott explained this much better than I did, but that's what I was trying to say with the integrating commands into your paths. On Path Planner, it's harder to kind of drag and drop those commands or have the things that are called name commands. You can't integrate as much logic or use any outside sources like cameras and stuff otherwise, other than just kind of odometry for your general position. We had some people on our team working on object detection, and hopefully if that works out, we were actually thinking about that too, having a way to kind of run different paths, have more, like Scott said, conditional logic, where you would run particular paths or particular segments of paths based on kind of what you observe around you. That would make the most of the autonomous period, because like you said, it's really short. It's hard to waste a lot of time running a path out to like the center line if there's nothing there for you to get.
Out of curiosity, how did you go about object detection? Did you like just do like based off color, or did you like use a neural network?
I wasn't working on object detection for a while. Some other people on our team were, but we were using cams that had color detection, and they were detecting
Pixie cam.
For yeah.
Oh, Caleb's on. Caleb, can you
I'm on here. So in season, For state, we tried using a pixie cam, just looking for orange. That didn't work super well because of the lighting. But off season, we tested with Photon Vision with the pre-trained model that Photon Vision provides for the note using a color ArduCam. I forgot what the model number was, but that worked really well. We had one of our other students start writing a command to create like a note centric mode where you'd press it and just drive forward and it'd go to the note. Um, and I think that worked pretty well, but you're kind of relying on Photon to come out with that model because there's not currently a way to upload your own trained object detection model.
I guess like that's a benefit of using OpenCV Oval Photon Vision is you get a little bit more customizability, but the risk there is if you can like make sure it works in time for season.
Yeah, and with like a Limelight, you can train your own models with the Google Coral. So that's an advantage of that method. But Photon Vision will likely come out with a model every year now for game pieces. But a thing to note is you do need an Orange Pi with the RK35 something chip. Otherwise, it won't work because it needs an NPU.
Specifically for the Photon Vision, in your experience, were there many like false positives that you like? Was it detecting any notes that weren't really there, and did that affect?
Initially, it would detect the gem floor because it was close enough to orange-ish. But you can tune it out pretty quickly if you just increase the minimum size because it was just tiny little blips. But otherwise, it's pretty reliable.
On the point of name command, something I was trying to implement in Chicken Flannel is adding an interface above constructors, so that way like Chicken Flannel as an app could maybe have JSONs with parameterized constructors being saved to your paths and just like being able to load. So that's something we're trying to do. Really the main issue of that is what happens if you change your commands and like you have a previous path. I haven't really thought of a good way to solve that, but it's something we're looking into.
I'm curious how teams are solving the problem with reusing paths, sharing paths. So, for example, last year you could pick up 3 to 4 notes during auto, and you might say the first segment of our path is always going to be this note, but then that path could be reused for several different autos. But then there may be just going from note 1 shoot and then go to note 2 that might only ever be used by one auto or maybe just 2 autos. Do have teams come up with a good strategy of how to use those path segments, name those path segments, organize them, connect the dots between them? It seems like in our experience, and if Fulmia might be willing to share more information about that, but we constantly were like, yeah, this became a big mess and we couldn't figure out what was where and which pass was what. And then we kind of start over with how we name things or how we organize things. Just curious if anyone else is trying to do sort of segment reuse and how you're approaching that problem.
So 3926, we basically did something similar. We had like we made like small segments on Path Planner and then we named them things. For example, one of our names for like, let's see, the center, like we gave numbers to each note. So for like the second note down from the top, we named it C to F, which went from the like the 3 notes like down on the left. We would go from the middle note to the center one, and we had like a bunch of abbreviations for each of our segments, and then we just made it into one. Well, and then we reused those like positions if we had like a robot go to that position for each auto. So we had, how many autos do we have? For example, we had a 5-note auto, and we also had like an amp auto, and we had like a bunch of different autos, but we still reused a lot of the segments that we did, and we were pretty consistent in the naming. I don't know.
I think the main concern with having autos that complicated is how do you like test for like every given scenario? Because like the more like if statements you add to an auto is like the more difficult it becomes to make sure that it's reliable. Like even if an auto is a bit slow, maybe a bit less efficient, if you know it's gonna work every single time, it might be preferable to something more complicated.
Yeah, I agree. I think that with our experience in creating paths, at least once it gets once it gets more complicated, it becomes more difficult to kind of reuse. I know that for our team, we really didn't reuse any paths, but we ended up making our paths tailored around a certain, already knowing what we wanted to do in the auto in that specific during that specific path. So at least from our experience, it does kind of get difficult to reuse them since they're already kind of tailor made around a certain uh, instructions.
It's definitely a trade off because on one hand, if you're reusing your segments and then if you change one, now you've changed it for all the autos that use that segment, and now you got to go back and retest all those autos. But on the other hand, as the tournament goes on and as robots are banging into, let's say, the subwoofer, and they're moving that wall back a little at a time, that note is then now in a different position from if you're starting at the subwoofer, that note's now in a different position from the subwoofer, and you could change it for one path segment, and all the all of the autos are updated for the fact that it's now 3 inches further away, or potentially even more. I know that you guys are way too young for this, but Steamworks, that was a really big problem because robots were banging into the airship, and that airship was slowly moving across the field, and you were constantly tweaking your autos so that you could get that gear on the peg throughout the match, because that airship was way too big and way too heavy. Field reset was not going to try to put that back into the original position. And in like our loading stations, right, we bang on the wall for the loading station, and that corner slowly moves out. So yeah, it's really tricky. I think the nice thing about things like using Path Planner, or what you guys are working on doing, or even manually coding your autos, is that you need to be able to update those points during competition because the field moves. And I think that's an important thing to keep in mind when you're looking at how am I going to create my autos. It also has to be how easy it is to update this, and just trust that it's going to go to the right place because you don't have the ability to test it. Well, I'm happy to end early. I'm never going to say no to ending at an hour instead of an hour and a half if everyone wants to. Let me do this. I'm going to give my pitch. So for everyone who was on the call, I know that we have quite a few new people on the call tonight because I got a lot of new signups from Jumpstart yesterday to the mailing list. One of the things that I really love to do this year, and we've gotten really great feedback on the couple that we've done so far, is a get to know my team. And so far we've had a get to know Mythic, and we've had a get to know the gears out of Blaine. And so those presentations went really well. They were a lot of fun, a lot of great questions. The gears decided that they want to do sort of a 2-for-1. So they did half the session on get to know the gears, and then they did half a session on how they do their budgeting. That was super awesome too. So if you don't feel like you can fill the whole time on a get to know our team, you're happy to kind of combine it with something else if you want. So I would highly encourage, and I'm honestly pleading with you, please come with a session, sign up to say, get to know my team, and pull together information about your team. It can be anything you want. How you do recruiting, how you do fundraising, how you organize your leadership, how you pick your drive team, how you organize your sub teams, if you even have sub teams. how you approach design. There's just so many different things, and so many teams do things different ways. It's so interesting to hear how different teams are operating and organizing. So if you're willing to do that, please sign up. Otherwise, I got to make something up with no advance warning and come up with a topic for us to discuss by Friday or Saturday so that we can do it. So I'm pleading and I'm encouraging everyone, please sign up. Also, as another part of my sales pitch, if you think you might be a Dean's List candidate, giving a presentation like Emilio and John did tonight is great conversation stuff for a Dean's List interview. It's great for an Impact Award if your team presents for that. So I would also encourage you to leverage this to your heart's content. Plus, it's recorded. It's on YouTube. So if you give a presentation like John and Emilio have, now it's up on the internet and you can point people to it, and you didn't have to figure out how to record it or any of that stuff because the roundtable takes care of that. Anybody? So let's do this. Any closing conversations anybody wants to do? Otherwise, we'll wrap up 20 minutes early and I'll go watch Sunday Night Football. Anything?
I only have one question, and this might be a future Nightcrawler conversation topic. Would be like, we're a smaller team, but we've been looking at trying to do using CAD software for our parts. We do a lot of our prototyping with like using plastics and woods and doing 2D stuff, and it'd be really nice to AutoCAD them up rather than just doing the 2D drawing. And we're kind of looking at getting into that, so that's something we're interested in.
So Riley, thanks for the topic idea. Last week, Isaac gave a presentation. Was it last week? I think it was last week. Isaac gave a presentation. No, it was 2 weeks ago. He gave a presentation on machining and CNCing, and his was kind of a little higher topic. It wasn't a how-to. There's been at least one or maybe two Onshape demonstrations on how to design your parts, and then you can export the step file or the DXF file and run those to the CNC. So I go back and look at those. But doing a step-by-step, I think that would be a really great thing to do, to say, go from your CAD software, which I think most people use Onshape. Can you guys just shout it out? What do you guys use? Onshape? Are you using SolidWorks? Are you using something else?
3926 uses Onshape.
3082 uses Onshape too.
Yeah, 2530 is all Onshape. We do CAM in Fusion 360, but everything for CAD is Onshape.
Maybe what we should do is we should put together a step-by-step from Onshape into Fusion, because those seem to be the two most common things that teams are using for CNC, router-based CNC, spindle-based CNC. That's a good topic suggestion. I like that. That's probably something that I could even pull together, or I could maybe twist Isaac's arm to come back on, and we could do kind of a walkthrough of that. That's a great suggestion. Anyone else have suggestions? I mean, we got time. What do you guys want? Because then it makes it easier for me to pick a topic.
I want Isaac to post his feeds and speeds.
Okay. Yeah, that's true. The feeds and speeds, man, he spent a lot of time this summer fine-tuning our feeds and speeds for aluminum and polycard. I don't even know where the library is. I need to get in touch with him on that too. And where are you buying your end mills? What end mills are you buying? I think those would be getting really down into the details. The high level stuff he gave, that was a great presentation. It was the same presentation he gave at Jumpstart yesterday. But we could really dive in deeper too and do an example. That would be great.
I think something that would be helpful is even if you have a DFM subject, if you're not making a decision between in-house versus buying something, how do you decide what to make in-house? What do you decide to go to a vendor for? That kind of stuff would be very helpful.
Ben just posted in the comments a link to GitHub. Those are feeds and speeds for Fusion 360. That's a good discussion.
Gold. Thank you.
Okay, so Deepak, I know that there's a student on Inconceivables who has a presentation that sounds like it's a lot like that. And so hopefully, Dr. B, that's one of your students, right?
Yeah, we've got ecosystem for like gearboxes, motors, etc., and also what to build and what to send out. We could possibly do. We've tried to do everything in house because we don't have a lot of resources. But yeah, what you decide to do yourself, what equipment you use to do it, and then what you send out is actually a really good topic. And it
Yeah.
probably takes more than just us. There's a lot more experience outside of our team for sure.
But
And
I would,
I know our team has a lot of in-house resources, but it takes some time and resources and effort to get a mill running and get some students up to speed on how to actually make parts that we can use on a robot. So that would be very helpful.
and I will say that don't be afraid to host that topic yourself. I use this example a lot, but Talon gave a talk on how to properly wire a robot, and every slide was tell us how to do this, tell us how to do that. They weren't giving any advice at all. They were seeking advice, and it was a really great conversation. So even if you just so for those that are new to the Sunday Night Call, this does not have to be a presentation. It can just be a conversation. Most of the roundtables are just conversations. So if you have something you're interested in, something you want to talk about, the link is in the email that on the mailing list. If you go to team2052.com/roundtable, there's the link to sign up for the mailing list. There's the link to sign up to host a topic. There's a link to the playlist of every YouTube. This is YouTube video 56. This is our 56th roundtable. So there's a playlist out there for those. Please, I can't say it enough times. Go sign up for a topic. It'd be great. We actually have 2 topics already in February. So I'm very excited that we're already thinking out to the build season, but most of the rest of the year is empty. So please, if you want to talk about your team or talk about a topic, I encourage you to please sign up. Yeah, go ahead, Emilio.
Something I personally would love is maybe like get to meet the mentors as like a topic of just like maybe FLC alumni kind of explaining how FLC helps them in the work environment and kind of like what happens to like FLC students after they leave high school, and then just suggestions on how you can like maybe break out into those fields. Wow.
Okay, I'm excited about this topic, but this is a hard group to reach because I don't know how to get a hold of a lot of our alumni. I mean, there's probably 3 or 4 that I could pull in from Nightcrawler, but it's not nearly as easy as getting hold of a mentor or a student. But this would be a really fun topic. I would love to see where people have ended up coming out of robotics.
I like that a lot.
That's a neat idea.
Person for that topic.
That's a really neat idea.
Yeah, that'd be cool. I've got one mentor, actually 2 mentors now that are former FRC people that are doing super interesting things with aerospace and who knows all what. So it'd be really fun to have them talk about where they were and now where they are.
I sat at Jumpstart yesterday. I sat in a little group of people, and Tyler from Fire Bears, he's a mentor. He's a first alumni, but he's also a mentor now and a volunteer at First Events. He's a robot inspector. And Lori and a few other people were talking about how many alumni do we know that we could bring in as a volunteer and have like 100% alumni volunteer regional, like all the robot inspectors, all of the queuing people, all field that they're all volunteers. Maybe I should put this on Tyler. Maybe Tyler and Lori could work together to get us a group of alumni. The roundtable, Elsa, it is team2052.com/roundtable, and I will type it in the chat right now. That's kind of the jumping off point for everything. So that is where you'll go in order to sign up for the mailing list, see the YouTube videos, sign up to host a topic. You can find that all on that page that one of our students put together. Well, I tell you what, I love this topic. I think you guys did a great job with the presentation. I think our follow-up conversation was really awesome. I am ready to wrap it up unless anyone has anything else they want to chat about.
I think I'd just like to say,
oh, sorry, John.
No, I was just going to say thank you for having us on. It was a really good opportunity for us to kind of reach out and network with other teams.
Emilio, did you have something?
Pretty much me and John were saying the same thing at the exact same time.
Okay. And I want to give kudos to the students. This might be the first roundtable we've had since last year, where the students were doing pretty much all of the Q&A during the presentation. The students talked way more than the mentors until I got on and started my big mouth here at the end. I really, really appreciate the students had their cameras on. You guys are great. This is what the roundtable should be. It should be mostly students chatting. So we want to create this environment. I know that I'm the loudmouth who hosts the call every night, or every week, but we want the students to really build these connections. So we really appreciate you guys who are asking the questions and joined us tonight. It was really great. And thanks for turning your cameras on. It helps a lot. Alrighty. Anyway, I don't know if there is a topic for next week. I suspect not yet, but I will see you next week. We'll do something. Watch for the email. I'll pick a topic if I have to. And then the week after that's Thanksgiving, so we won't be doing a call that week. And we'll start up again in December. So see everybody next week. Thanks all.
That's it for this week's FRC Roundtable. Join us live all season long, every Sunday night. Visit the website at team2052.com/roundtable to sign up for weekly invites. In the meantime, keep building, keep learning, and we'll see you next week.